Welcome in English. Welcome to Econ 1910, the Garage Auditorium. So you are all busy doing the term paper now, and Kalle is doing the lectures about parasites and corruption and all these things. So I thought I would just give a little wrap up of some important issues that we did before, at the start of the term. We had a couple of models or descriptions of an economy, and then Kalle and I also started doing growth. And there is something about the equilibrium that shows up in these three different settings that have important similarities, but are also important differences. So I thought we should have a look at differences and similarities in the equilibrium in three different settings. So the first is this one that we started out with. It's a farmer who is able to produce on the land, getting this marginal income. But there is also employment opportunity in the town, giving this income, W, assumed to be fixed. And then the question for the farmer or the family is how many should work in the city and how many should work on the farm. Then we have another one here, which is in a way a whole country with the agriculture sector here and the manufacturing sector here, and then the return to labor in agriculture being declining in the number of agricultural workers. The same in manufacturing. The return to employment in manufacturing is decreasing in the number of manufactured workers. Then we have this one, which is the growth story. We have capital here, and then we have a savings curve, which is a certain fraction out of production being saved, and that is the saving is also being invested. So savings is equal to investments always, and all that is saved is also invested, so there is growth in the capital stock as a result of this, and then there is depreciation eating into the capital stock. So in a way, whether there is capital growth or not depends on the race between savings and investments. If savings is higher than investment, if the race between savings and depreciation is, if savings are higher than depreciation, then there is capital growth in the capital stock and vice versa. So then the equilibrium here is this point where these two curves cross. It's this point where these two curves cross, and it's this point where these two curves cross. So the crossing is the equilibrium in all three. But how the equilibrium come about and how we should view the out of equilibrium cases is equally important. So the equilibrium is important, but also the out of equilibrium is important. So here it's one person that decides. So then the one person who decides look at this return and that return and do the best out of that, shifting resources around in order to make the best out of it. So it's a one person decision, and the logic can be used for a farmer. It can be used as Robinson Crusoe, the lone shipwrecked guy on the island. So it's a very homo economicus, single person logic. So then, well, the farmer will soon figure these things out, and if the farmer is rational, and if it's possible indeed to get this wage, and if this is the return, it will be a matter of weeks until the farmer realizes that this is the optimal point. So then it's in a way a quite easy question for the farmer. So we can assume that if there are no other constraints, then the farmer will soon settle at this point. Well, these many hours we spend on the farm, the rest we spend in the village. Okay, so then equilibrium, or the efficient point for the farmer's point of view, is here, and we can assume or hope that this decision to employ workers until this point at the farm and so on in the city is achieved quite fast. If we go to this, the setting is looks similar, but it's very different. What's different here is that, well, there is a city and there is the agriculture sector, and we have like millions of people in this setup. So then how is this equilibrium achieved? Well, it's achieved by people moving from the countryside to the city. So if this LA was all over here, then the wage in the city would have been much higher than the wage in the agriculture sector, and people would start to move to the city. When they start to move to the city, the wage in the city go down, the wage in agriculture goes up, and when this process continues sufficiently long, we end up here. So it's a case where when we are in this point, no one has the incentive to move to the other sector. And then migration stops. But then, if we are over here, large agriculture sector and a very efficient and modern sector wanting to hire people, there will be migration from the agriculture sector to the city. So it's the story here. It's not, or the story we want to take home is not the story about this equilibrium being the important point. Well, the equilibrium is an important point as the end point of the process we are interested in. We are really interested in migration. So then we want to understand what are the forces that drive people to move from one sector to the other. Well, it's wage differences. If that is the case, there will be migration from agriculture to manufacturing if agriculture sector is very large relative to these labor demand curves. And it will be migration from manufacturing to the countryside if the manufacturing sector is very large relative to agriculture. So then we can use this model to discuss what happens if we are away from this equilibrium. And most countries are always away from that equilibrium. It's never the case that the wages are equal in all across the country. So all these differences in wages across the country or across the sector explains how people move or take education or do different things in order to get into the booming sectors and get out of the declining sectors. And this is an ongoing process. All the time there is something happening that leads people to move, either by choosing another education compared to the parents, or to move physically from one sector to the other. So this is a story about out of equilibrium, we could say. But the equilibrium is still important because the equilibrium tells us when these processes would stop. But maybe the economy never gets there because there's so much going on, these curves shifting up and down all the time. So this equilibrium is perhaps never really reached. But it's nevertheless interesting to work out what would such an equilibrium look like. So then we go to this, which is even more, well, this description of growth is very much about other points on the graph than this equilibrium point. Because what does it tell us? Well, it tells us that if capital stock is low, savings is higher than what is needed in order to replace the depreciated capital. So as this is larger than that, there will be growth in the capital stock. So here it's not about incentives to do anything, because here is the capital stock that accumulates as a result of these differences. So then this is in a way a mechanical exercise. It's not like we need to assume that there is a sensible person deciding anything really, because the capital stock is what we consider here. Here there are people. People, in order to move people around here, people have to decide that they want to move. In order to move people here, the owner of the farm needs to decide that we should put people to work here rather than there. Here, it's the capital stock that is added onto as soon as this is higher than that. The capital stock is reduced as soon as this is lower than that. So then this is like what should I say, a robot, a machine. We just crank it up and then it will start to move according to this rule. So this is a rule about capital growth. And then we have growth when capital stock is low. We have negative growth if the capital stock is very high. Maybe not super relevant for poor countries, but anyway, we know that. And then we know that if the capital stock is very low, there is a relative large gap here, and the capital stock growth rate will be high, because the gap here relative to the size here means that the capital stock will increase by a large percentage every period. So then this is a story about growth. If we want this to be a story about growth, we have to consider points that are not in the equilibrium, because the equilibrium, that is a story about no growth. Growth happens here. Equilibrium means that the growth has stopped. So it's not really super important if we want to understand growth. But anyway, it's important to know where this point is in order to know how strong the growth will be if we are to the left. The same here. This is a story about growth. This is a story about migration. And again, if we want to understand migration, we need to know when migration would potentially stop. And that would be in the equilibrium. But if we want to have a model, a story about migration, we need to consider out of equilibrium points. And then we go here, and I said that the equilibrium is, it's easier to assume that we will be in equilibrium most of the time. But then we can consider, well, maybe there is something going on here, that the farmer doesn't get everything that is produced. Then this point, which is efficient, will not be the equilibrium any longer. So that would be the case of sharecropping, where maybe this is the return that the farmer gets, hence there will be less employment on the farm. So then this curve can be used to discuss what happens with income shares and whatnot if something happens to these curves. But we always compare the old equilibrium to the new equilibrium, or the equilibrium when the black is valid to the equilibrium when the red is valid. So here we compare equilibria in different settings. When we do that, we do something called comparative statics. We compare the equilibrium in one situation to the equilibrium in another. What we do here is to look at the equilibrium point, but we make stories about dynamics. Here it's clearly about dynamics, it's about growth. So comparative statics is what we do here. This is when we use it to discuss migration, it's about dynamics, but we can also do comparative statics here, like looking at what would happen to income shares and whatnot if there are investments. So this is in a way a hybrid. We can use it to dynamics, but we can also use it to what I call comparative statics. But here it's about growth. So then it's really the process leading the economy on its way from here to the equilibrium up here that we're interested in. Okay, so I stop here in order to make this reasonably short. Okay, thank you.